All right. So yeah, thanks Josh for introducing us. Yeah, we're definitely hiring, and you're probably going to end up talking to me. So feel free to reach out to me afterwards, or shoot us an email. So my name is Eric LaForce. I've been a software developer for about 8 years now. I worked for Duke Energy for 9 months and got the hell out. Then I worked for Bank of America for 2 years after that. Bank of America is actually where I learned a lot of the stuff that I'm going to be talking about today, specifically because of the scope and size of the system that we were working on. It required more of these types of things that you don't typically run into when you're working on, some smaller projects. So that's kind of where I learned a lot of this stuff. So even though I didn't particularly love the bank long term, it was great for me and kind of learning those things while I was there. So it was a lot of fun. So as I said or as I'm going to do, talking about software patterns today, I apologize. There might have been some confusion potentially on what this talks about. This is specifically about a development topic. This is not things like graphical user interfaces or those types of design. It won't hurt my feelings if you stand up in the middle and leave, so keep that in mind. So as I said, what could this term mean? I'm not talking about UI. I'm not talking about UX. I'm not talking about product. I'm specifically talking about coding and building code that's maintainable. I'm not talking about beating your opponents in Counter-Strike, because as we all know, I'm going to be doing that later today. We're having a LAN party later for those who don't get that joke. So, what is kind of software development specifically? It's really for building maintainable code. Uh, some of you have probably already used these things and you don't even realize that you've been using them. You haven't put a name to it. You've been doing it because it feels right, it looks good, it makes the code cleaner, but you just didn't have a name for it. I like to think about software patterns kind of as a recipe, more so than a blueprint. I really hate when people talk about software and they describe it as a construction, right? Like, it's not construction. I'm not taking this blueprint. I'm not taking this like very well defined set of requirements and building something. Like, that's where people run into problems. It's very much more like being a chef. I have this recipe. I'm going to do a little bit here, a little bit there. This used to work for me, in a previous project, but it's not going to work on this project because of X or Y or whatever. And so that's, for me, that's what software patterns are really about, is understanding the recipes for success, which sounds really lame. So I apologize. All right, so maintainable code, that sounds awesome, right? Cool. So what does maintainable code mean? So maintainable code is something that's really going to stand the test of time. It's going to weather this storm of feature requests and bug fixes and performance updates and just everyday use. Really what it means is I'm not going to be rebuilding this product 6 months from now. I'm not going to be rebuilding it 5 years from now. We're going to be constantly refactoring and using these patterns and working together with a team and with our clients to make a product that's going to actually last. So that's why I love these types of things. Note, these things are also for what we call object-oriented programming languages. This is not for, say, a functional language or a declarative language. Those do have their own patterns, but I don't have time to cover those today, so we won't be going over some of that stuff. And finally, specifically, design patterns are also about building a ubiquitous language. So, I go and talk to my brother Keith and I say, hey, Keith, we've got this problem. It's a command pattern. And Keith says, okay, great. I know what to do now. So it's really just about building that language with a team. All right, so where do we go from here? So first, to understand what's good, let's focus on what it means to be good and what's actually bad. Anti-patterns. So anti-patterns are particularly interesting, and people, developers especially, they'll laugh when they see these types of things because they've probably seen them before. But I think it's good to kind of build, again, this ubiquitous language and get an understanding of where we're going. We really want to make sure we get these kind of undesirable patterns out of our code bases. All right, big ball of mud. This is probably the most common and probably the one that people would recognize the most. It is essentially a system that lacks any perceivable architecture. This is a system that you had some French developer build for you over the past 10 years, and it just kind of is what it is at this point, type of thing. So you've got the most unmaintainable system possible. It's tough to add new features. You can't track bugs. You can't train new devs on it because they get in for 3 months, they hate themselves, they quit. So how do we avoid this disaster, right? So using the software patterns that I talk about today is going to get you there, but really it just comes down to using your head and using a little bit of foresight into the things that you're building. You can't just write code. You actually have to think about it. And that's nothing against developers. That comes off, probably worse sounding than I really mean it to. It's really about pushing back on your clients and saying, I can't do that because that's going to cause us a problem a year from now. If you want a system that's going to work long term, I can't work an extra 20 hours, get this thing out the door, and hope for the best. So that's the kind of thing we're hoping to avoid. So how do you get out of it? So I've seen this before, right? We've got this system. We really don't want to spend the next 3 years rewriting it, so how do we start working through this? It is a pain in the ass. That's what it's about. It's going to take patience, it's going to take a lot of effort, and it's going to take your entire team being focused on fixing that problem. Essentially you have to really take a look at it, go over it, understand what the requirements are, and then start building a unit test suite. That's my number one recommendation for getting out of a system like that is you take this very small piece, you build some tests for it, you move on, you feel comfortable with it, and you just keep doing that, one small piece at a time. God objects. All right, so God objects, knows or does too much. It's one of these classes that has so much state in it. It's got so many methods in it. There's so much functionality. It's hard to test. It's brittle, meaning it's hard to modify. If you change any implementation details, the whole system crashes down. And the big thing, too, is it's hard to wrap your head around something like that as a new dev. You come in and there's a 14,000 line class that you have to somehow understand what it does, So some people like to call these utility classes. Yeah, they're dead wrong. There's no utility in something like that. So how do you avoid it? There's two principles that that you can use. One's called law of Demeter. One's called single responsibility principle. I can talk about them afterwards. I didn't want to spend a lot of time digging into them because they're kind of worth their own talk. But specifically, they promote loose coupling, and they thus help you avoid this kind of epitome of type coupling that is the God object. So how do you get out of it? First, you have to understand what the God object is actually doing, maybe even document it if it's necessary. Once you understand it and understand how the different pieces are connected, again, the same thing we did with the big ball of mud, we just start breaking off those little pieces. The God object's actually a little easier, though, because it's a single class as opposed to an entire system that you're trying to refactor. Again, use unit tests. The inter-platform effect. This is probably one of my favorite ones. I think it's just really interesting that people do this. Jonathan Rose, a developer at Skookum, actually introduced this to us when I was at the bank because we started down this path, and luckily he saved us from what was going to be a very bad system long term. So developers like to customize stuff. They assume everyone else wants to too, and so they like the idea of building a system that gives people a lot of flexibility and doing whatever they want. What you end up doing, since you're in the developer mindset, you start thinking about, well, I can do this, so why wouldn't my users want to be able to do this? And you start replicating in your system what your development platform allows you to do. And so that's why it's called the inter-platform effect, is you're basically replicating what's possible with the development platform, except you don't have a PhD in languages, so you're ultimately going to make it worse than the original development platform itself. So how do you avoid it? You just be vigilant. It's the same thing that Jonathan Rose did for us. Hey guys, we're heading down a bad path here, points us at it, and we say, oh yeah, that's exactly what we're trying to do. And so at that point, we could back out and come up with a different architecture that wasn't so focused on configurability and flexibility. How do you fix it if you're there? You're kind of stuck, actually, in this case. There's not much you can do. You could remove it, but there's probably users who really like it, right? There's a small segment of users that actually enjoy that level of configurability, so you're going to piss them off when you remove it. But if you leave it, it's not good either because of performance and reliability. So probably the best case is you just have to remove it and ignore that small set of users that are complaining at you. So the next one is interface bloat. So this one's interesting as well. So this is actually talking about a software interface, so essentially defining a contract for a particular set of methods to follow. The idea being, if you got too much in one interface, everything that implements that interface has to implement all those methods. what you end up doing is a lot of things you're like, well, that doesn't actually make sense in this context, so I can't implement it. So you put little throw new exceptions, not implemented type of situations in your code, which, long term just doesn't make sense. This one's fairly easy to avoid. You can follow what's called the interface segregation principle, which essentially states that no client should be forced to depend on methods it does not use. So if you're just very straightforward, break things up into smaller chunks is really what it comes down to. And so how do you fix it? You refactor. So your interfaces are too big. You think to yourself, let's break it into two. I'm going to take those two, break it into two again, so on and so forth until you get interfaces that actually make sense by themselves as opposed to putting in the entire set of functionality in one place. Object orgy. I didn't want to put a picture here. It's just too much. So within an object orgy, objects are basically they're insufficiently encapsulated, which means clients of that class have the ability to see its internal state. So they just reach in, grab whatever they want. It gets messy real quick. So if you break encapsulation, though, it just makes it very difficult to reason about the system, which leads to things like the big ball of mud. It makes it very difficult to re-implement that functionality because of all these unknown connections and all these people who have their hands where they shouldn't be. So how do you avoid it? Use your language features. Things like access modifiers, discipline. Just make sure you've got a good understanding of who's using your system and who's not. So how do you fix it? Again, patience and discipline. It's going to always come back to that once you get into these types of states, is really just being disciplined as a team to track down those things and resolve them. All right. So that's a quick overview of what's bad. Now we're going to go over some of the specific design patterns that I like to use and I just think are particularly interesting. So we'll jump right into it. The first one is chain of responsibility. So we'll start with an example. So if I'm building a compiler or an interpreter for a particular language that has exception handling, I know that I'm going to have try-catch blocks. Those try-catch blocks can be nested. So I could write code that tracks that nesting all the way down. Put in an array, it'll be fine. No worries. Problem you're going to run into there is you're going to get into a lot of overhead. If you get down, I wouldn't normally want to do this, but if you get down 10, 12, 15 try-catch blocks, it's going to be hard to start tracking what's what and what's nested. So we can use something like chain of responsibility, which really what it does is it gives an object it gives more than one object a chance to handle a particular request. And when I say request, I'm talking about, asking for some information or trying to perform some type of operation. The objects are chained together basically via a successor reference. And so kind of in the participants diagram here, we'll see basically, we have a handler, and you can see I've got the success handler here. All it is referencing the next step in the chain. And so the idea being that, you've got this chain, and your client really just has to track the first one, and then the chain kind of handles all that functionality for you and knows what the next thing to do is the idea. So the handler basically is just defining an interface for handling these requests, and you could optionally implement the successor link. You don't have to. If you're really going to have a chain, though, you need that successor there. The concrete handler, it handles requests it's responsible for, and then if it decides, hey, that's not for me, it'll forward it on to the next series of the chain. And then finally the client, it's the one that actually initiates this kind of concrete, or initiates the request itself, essentially. It's the beginning of the chain. So why do we want to use this? Specifically, we want to use it because it ensures that objects are appropriately encapsulated, and it avoids kind of this tight coupling that we may build by tracking all these references throughout the code. It also ensures that objects maintains a single responsibility. It improves maintainability through the flexibility of the system. Like, I can add a new handler in, and I'm not going to break any of the existing handlers. It's just a new part of the chain, but all of a sudden I've changed kind of the business rules or the business logic around that without worrying about, how is this going to affect my system long term. And finally, this one actually helps you avoid object orgies because it's all about the encapsulation. So when should I use it, which is probably the most important question of these types of patterns. You want to use this when you have more than one object that can handle a request. You don't want a bunch of if-else logic in your code that says if this, do this, etc., all the way down. You could actually just turn it into a chain that then handles it. That if statement actually becomes part of that one object, and instead of having a bunch of ifs in one place, you can kind of spread that out over a bunch of small objects. You want a request to be handled by multiple objects, but you also don't want to hard code, like, who's the endpoint here? Like, I don't really care. I'm just going to hand it to the chain, and somebody down the line is going to figure out who's responsible for that. All right, next. So the command pattern. So the command pattern's kind of interesting. It's used, again, to encapsulate, but it's also used to package up all the necessary information to invoke a method or a request. So this makes it easier to do things like queuing up requests, logging requests, and specifically when you hear command pattern a lot, it's really about undo operations. So in that way, kind of the example I give is a rich text editor. So in a rich text editor, oh cool, I've always wanted to write a text editor, said no one ever. But they're writing it, okay, that's fine. So they start tracking these formatting changes. Okay, I bolded that word, I italicized it, that type of thing. Well, that works pretty well. Oh no, I have to support undo. So you think, okay, well, I'll just add another method that'll undo the bolding. And then you end up with this God object where you've got 1,000 methods to do all the different formatting options. And I'm describing a real case. Like, this is code that I've seen written that I had to refactor. So it's, it's a real thing. People do it. So it's an easy path to get down because it feels easy at first. But then down the road, you're like, man, I've got this huge object that I don't know what to do with. So if you do it with commands, you can actually set it up in such a way that it handles that undo operation. So the participants on the screen, we have a concrete command, which essentially implements this execution method, and it defines kind of the relationship. The client, of course, is the one constructing the command and letting it know who's going to actually do the work. And the invoker is interesting because it's the one that's actually going to perform the operation. And this is where you can do things like log it. So I can log every request that comes through my system. I can queue it up for later use. And then what's really nice, you actually throw it on a true data structure queue. You just start popping stuff off, and that undoes kind of what you were doing before. So that's where people use the command pattern a lot, is for that undo functionality. So why should I use it? Really, it's about decoupling kind of the invocation of an object and really which object that knows how to perform it. It's also just really about improving, again, the maintainability and the flexibility of your system. I can add new commands. I can compose commands together. So if I want to do a bold italicize, like I've got one command that does bold, one that does italicize. Like I don't have to build this call three methods type of thing. Like I can just compose those together. It gets done as a transaction. All right, the next one, Decorator. So Decorator is really about adding responsibilities, and I'll talk about that in a sec. The example I like to give for this is a user authentication system. So, maybe it starts out simple. Well, I need an admin. I need a read-only. That's okay. So the user read-only, I'm assuming my admin is going to have the same functionality as that user. So what I can do is like, well, okay, I'll make an admin user that inherits from that. So it gets the same functionality, and I'll just add some new methods on top of that. Boom, I'm done, moving on. So that works great. A year down the road, they say, hey, we're going to add a whole bunch of people. We're growing as a company. We need 1,000 roles now. And you're kind of like, oh, well, I can't add 1,000 objects into my system because I'm going to have all this functionality spread out across all these different things. Maybe they want to share responsibilities. So that's where the decorator comes in handy. So it's really about providing a flexible alternative to doing that subclassing idea, and you're dynamically adding responsibilities on top of an existing object. Now notice I said object and not class. So at runtime, I'm adding these responsibilities on as desired, and that means I can also remove those responsibilities down the road as well if I want to do that. So the participants, the component. So this is, kind of the object essentially that, or it's the interface for the objects that can have responsibilities added. In that light, I wouldn't create like a generic decorator interface that you can just add whatever you want to whatever. Like it needs to be specific. So in this scenario, I'd want to create a user decorator because it's going to have different types of methods than, say, a role decorator or something like that. So the decorator is, it's actually what's maintaining the reference to this component, and it's going to define kind of how that interface is conformed and kind of working through that. And then finally, the concrete decorator is the actual implementation of that, which does the actual adding of responsibilities to a particular object. So why should I use it? It improves maintainability in terms of you can add new behaviors onto an object without breaking existing functionality. So thinking the open-close principle. Additionally, it keeps a very simple, testable base class that we can use instead of running into like an interface bloat situation that I described before. When should I use it? Again, the most kind of important question. We need to add behavior to objects without affecting other objects of that same class. So again, we just want to add responsibilities to a particular level, but not do it for necessarily an entire class. If you can use it if you need to remove responsibilities from a class, and then finally when subclassing becomes impractical due to the large number of classes that need to be created. Flyweight. This one saved me again at the bank. We ended up using this because we ran into these exact same problem. The example I'll describe is not the same. The other one was long and tedious and boring, so I don't want to get into it. But kind of the default one is word processor. So again, for some reason we want to write a word processor. Characters are very important in a word processor. We're going to do formatting, we're going to do bolding again, similar to a rich text editor. But we want to make it super flexible, right? Like I want to be able to make each character bolded, each one italicized, underlined, what have you. So I think, okay, well, I'll create a character class that has a bold method or has an italics method. Great, no problem. This is going to work awesome until you open a novel and you have 1 billion objects that just flooded your system and brings the whole thing crashing down. So that's what Flyweight's really about, is kind of supporting a very large number of these fine-grained objects in an efficient manner so that the system doesn't come crashing down. So our participants, Flyweight. It declares an interface through which flyweights can receive and act on extrinsic state. And so what I mean by extrinsic state is, the state that is not kind of internal to that character. So for instance, if we're thinking about characters, the actual character A for a character, that would be intrinsic. Like it's going to be the same across objects no matter which objects you're using. The only thing that's different is whether it's bolded or not. So the bolded or not is really the extrinsic state that you need to keep track of, not taking up additional memory with the actual letter A again. Concrete flyweight, that's what actually implements the interface. The implementation from that is 5 lines pretty much every time. Gang of 4 is where a lot of this stuff comes from. They've even got like as a little tab, like the actual implementation just sticking out, and you can kind of see it here a little bit. It's pretty simple. Flyweight factory, this is kind of what creates and maintains those flyweights, ensure that they're being properly shared. And then finally the client maintains a reference to the flyweight and stores the actual extrinsic state at that point. So this one's simple as to why you should use it. It's mainly to save time and performance complexity. In terms of when, basically, any application that's going to use a large number of objects where you need to look for these types of optimizations to ensure that your application is going to run as efficiently as possible. All right. So the mediator pattern. So some of you have probably seen some of this stuff before. The mediator is kind of similar to the observer pattern, but it's more about a central hub rather than a single sender and receiver. The example that's typically given again is kind of with a GUI. So on a GUI, you have all these widgets that interact, and if you have a complicated enough app, there's going to be a lot of stuff on there probably. You click this drop down, it changes this button. You click that button, it changes, these adds 3 new lists to the system. You change those, and the whole process starts over. So the mediator is really about kind of managing those very complex interactions between these different things and making sure that we're not doing a bunch of many-to-many connections. So like my list view doesn't have a responsibility to know like it needs to update that button. It's more about kind of centralizing that behavior and making sure we have a kind of a single place where we're maintaining that. Now, kind of talking through this, what do you guys think that might lead to? Like if we start building this single location, what's that, Asaf? Yes, that's exactly right. So you got to be really careful when starting to work with some of these things, because it can really quickly actually lead you down the wrong path if you're not being vigilant. So we want to avoid the God object. So keep that in mind as you're working through a mediator pattern. So the mediator, it's going to define an interface for how these colleagues interact. The concrete mediator is, of course, the actual implementation of that and kind of coordinating these different colleague interactions. And then the colleague, of course, is kind of the object, the list box or the button or whatever the case may be. When should you use it? Specifically, it's again just for a set of objects to communicate in a complex but a very well-defined way. Like, you need to know up front how these things are going to interact. And if you start with this pattern, though, it does give you the flexibility to kind of refactor long-term and to continue working through those interactions. But it can't be a lot of if this, do this, if this kind of thing. It needs to be a very kind of well-defined aspect of it. The Memento pattern. Where's David? Is David here? David's used this before. So the Memento pattern. Here's an example. We have a project we're working on. We need to build an assessment engine. There's a lot of tests, a lot of questions, a lot of answers. The professors decide, you know what? Let's share these things. I hate making tests. I don't want to have to do it all by myself. Let's share the burden. So we can do that. So we share them. But these professors, they're a bit cranky. And so they say, you know what, I don't trust the people, even though I want them to help me, but I can't trust a single thing that they do. So what we want to do is we want to track every change in the system and make sure I can roll back to a previous version if I need to. This is kind of the opportune scenario for a memento pattern. Anytime you hear the word rollback or version, you need to start thinking about a memento pattern. So the memento pattern defines a way to externalize this internal state of an object without violating encapsulation, and then making it available to be restored kind of at a later time. So you click that undo button, it restores that state to what it was previously. So the memento stores as much or as little as the internal state as you would need to restore kind of the previous state. The originator is kind of the object in question, like the one that you're trying to maintain that state for. So it basically creates a snapshot of that memento in time. And then finally, the caretaker is kind of responsible for tracking that mementos and doing those undos when necessary. So why should you use it? Basically, it's ensuring that we're not going to open ourselves up to an object orgy by breaking the bounds of encapsulation. So we really want to take that state and put it in such a way that we can access it when we need to undo that state, but we're not just reaching into the object and changing it directly. So when should you use it? Basically, if you need to do versioning, like I said, or rollback, so some type of snapshot or portion of the object state that you may need to do. All right. Specification. This is probably one of my favorite ones, which sounds, again, kind of lame, but I've used it before to pretty good effect, and it comes in handy. So specification, imagine we're building some type of t-shirt design application. The client has these very complicated rules on what a design must have for it to be considered printable. So each rule is important. But it's only applied in certain contexts and only at certain times. And there's kind of all these really complicated things that you need to do to make sure it's going to work long term. So as you can imagine, it gets very tough to track something like that over time, and just especially those contexts and those different rules. So the specification pattern, what it does is it allows us to build these really small objects that represents those business rules. So the specification pattern brings the power of like logic programming, actually, to object-oriented programming. So it builds on the notion of what's called a predicate. When a predicate is essentially true or false. Does it meet this criteria? So some people call specification a value object, which comes from something called domain-driven design. But basically, it's just evaluating whether you have this other object to see if it meets that predicate. Is it true or false? And what this does is it allows us to break these things up into very small composable pieces that we can do together. So if it meets this specification and this specification or that one in this context, you start building those things up together and composing them together, but the real basic rules are all the same. And so it just allows us to think about that and kind of keep that logic in a very clean place. So there's only two participants in this one, the specification, which is just the predicate, determine if it meets the criteria, and then the object in question is the one that's being tested against that specification. So why should I use it? Mainly to ensure that all business rules are self-contained, they're small, they're composable, and they're testable. And this also, this can kind of help in certain situations to make sure we're not like doing another God object where we test all these different things and it's all in one class and those types of things. So when should I use it? Excuse me. We want to validate an object to see if it fulfills some need or if it's ready for some purpose. Maybe we want to select a series of objects from a collection, and so we can use these specifications to figure out if it meets that criteria. And then finally, when you have some business rules that can be broken down in these small composable tests, don't look at it and go, oh, well, that's a very complicated business rule. How could I possibly break that up? Like, spend some time. Like, most stuff really does break down into these very small tests of, is this true, is this not true? And so you can really just have to get creative with that type of thing. Finally, strategy pattern. Keith and I have used this one to great effect on a couple of different things. So imagine we're prototyping an application for a client. The prototype is intended to explore how users interact with an application. So we need to gather analytics. We need to perform an analysis on those results and kind of weigh the pros and cons of that. We could write a number of different methods that each do a different thing, or have some if logic kind of throughout that detects if it's doing a certain thing, or classes. Or we could just use a strategy pattern. So the strategy pattern is really intended to provide a framework for interchanging algorithms. So if I have a client who comes to me and says, hey, I want to do this, and then the next day they say, oh, I want to do this, and the next day they say, I want to do this, and we're like, well, we don't know what the right one is yet. So we can do all three, but let's do it in an intelligent way that allows us to test these things under different scenarios. So the strategy is, again, it just declares an interface that defines, how we're going to implement an algorithm. The concrete strategy is the actual algorithm itself, just kind of built into a specific class. And then the context is what's actually using those strategies kind of in the actual application. So why should I use it? Really what it does is it helps you avoid kind of hard coding behavior into that context and kind of making you subclass context, even though the context hasn't changed, it's just the algorithm itself. It helps to kind of eliminate all these conditionals or switch statements that you may end up with throughout your code. And then finally, it provides kind of a choice of implementations. Maybe you even give that option on the GUI, like, oh, I want to do it this way. Like, that's just a different strategy of how you're doing something. And so this is just a way to kind of represent that information. When should you use it? Really what it comes down to is this exact example of, well, I know there's a few different ways to do this. Maybe I want to give the choice. Maybe I want to test different scenarios. And so you can implement it in this manner. All right, so to recap. Anout patterns, they exist. We've all seen them. Fix them. Stop letting it go. Stop avoiding them. Avoid them from the beginning, too, when you start looking at things. Like, don't let yourself or your clients force you into that behavior because it's the wrong thing to do long term, and it's not going to be good for their business. Software and patterns exist. Who doesn't love to use a good recipe? There's tons of these out there. They're going to make your software better, and other developers will start to love you because they come into a code base and they go, oh, I know what that is. I've seen that before. That's a command, or that's a memento, or whatever the case may be. I have this code up, the link's here. I have code examples for each of these patterns that I've gone through. I've done kind of a few different languages. I did Python, Java, JavaScript, C# and Ruby. I opened it up open source. It's a good education tool if you ever want to try to implement something like this. You can just add it to this, just a different language implementation, and get an understanding of that. So feel free to do that. Hit me up on Twitter. Thanks for your time, and you can talk to me afterwards. Questions?
What if you have a member of your team, like you've read design or Daniel before, you love it, but the other team members don't want to participate? And how do you convince them that this is the right way? Swift kick in the pants.
Chuck said a swift kick in the pants. So the question is, how do you convince team members to use design patterns if they're not particularly keen on it? I guess it would depend on the situation as to why they're not keen against it. And I was talking with Asaf earlier, and he had used design patterns before, but it was in a J2EE kind of context where there's factories on top of factories on top of factories. Like, I wouldn't want to use it either in that type of context. It's really just about being smart and using them when appropriate. So it's really just about understanding, kind of why they don't want to do it, and then working it from there.
I forget which one of the don't do ones was the Matrix. What was that called?
That's the inter-platform effect.
Yeah, so can you talk about the psychology behind that? Seems just fascinating. The idea that like the creator of a world assumes that the population of his world also wants to be creators. Like how does that happen? Like, what's the mindset of a developer? And how do you become aware that you're doing
I can give the bank example that I ran into for that. So we were working on an application that essentially replaced Excel. You know, people at the bank love Excel. You know, it's so flexible. It can do pretty much anything. And so they wanted that in their application. So we started down the path of giving them the ability to do all the functional behavior that Excel does in terms of like formulas. And you can write a simple formula engine, like that's not too terribly difficult, but like they started wanting things like, you know, doing cell references and doing kind of more of these advanced Excel topics. And so from a psychology perspective, you know, like I just worked an 80-hour week. Now I got to talk to this client about some feature that they want. God, I really don't want to implement it, but they say they need it, so okay, I'm just going to do it. And so then you start down that path of, okay, well, how would we do that? Well, you know, in code, I could do this. So, oh, well, we could probably implement something like that as well for them, and that gives them the same functionality. And it's really just not looking up from what you're doing. And, you know, we were so thankful for John for, you know, kind of peeking his head above the water, basically, and saying, like, guys, we're trying to implement something that we do day to day, but do they really need this? And, you know, we're good at that at Skookum, right? But at the time, you know, it was something where, you know, you get so tired of dealing with those types of things, you just start to give in.
So there's a really common pattern I see that was failed to be mentioned. That's the spaghetti recipe.
Is that spaghetti code?
Yeah.
Spaghetti code and big ball mode are kind of the same thing.
They don't taste anywhere near the same.
No, it's definitely not the same taste. Great. Well, thanks everyone for your time. Oh, I'm sorry.
Any speculation on what anti-patterns are responsible for the failure?
Obamacare. I've had that discussion too recently. Yeah, that comes down to here's a big sum of money, get this done. Okay, we're gonna try. You know, and people just don't take the time to just think it through. You know, they're not thinking. They're thinking, what do I have to do today? Not how is this gonna work a year from now. Great. Well, thanks everyone for your time.